Find the amplitude, period, midline, and phase shift of this function. So for trig function, we can rewrite this so we have factored, well, let's put it like this. I can factor 3 out, so I have x minus 7. And this will allow us to find the phase shift a little easier. Okay, so let's actually find the amplitude first. Amplitude is absolute value of this number. In this case, positive, so it's just 2. Period for sine and cosine functions is always 2 pi divided by b. 2 pi divided by b. And b is this number right here. Or we can think it's this number, which is same. So 2 pi over 3. So every 2 pi over 3, this graph repeats. So then phase shift is, we can look at this. And whatever makes 0 here, the x value that will make 0. So actually, we could also just find the phase shift directly from here as well. Either one's fine. So if you look at here, when x is 7, we'll get 7 minus 7 equals 0. But also, if you look at from here directly, if I plug 7 here, I get 0 inside of parentheses. So for phase shift, just think as we're solving the inside, the input, the argument equals 0. And x here in this case is 3x is 21, x equals 7. Since we got positive 7, the phase shift is, we can either write just positive 7 or this means right to 7 units. So we move right to 7 or 7 radian. And lastly, the midline. Let me do it here. Midline is this number right here. This is positive 4 is y equals 4. So entire graph moves up to 4. Find the amplitude, period, midline, and phase shift. So for this one, actually before we begin, the fact that we have negative multiplied, like -1 multiplied to cosine, means it's reflect. Although it didn't ask here, if you were to graph this, it has to reflect over x-axis. Okay, so something to always keep in mind if it's negative number multiply. So let's find the amplitude. Amplitude is, again, this number absolute value. -1 absolute value is 1. So amplitude is 1. Phase shift. Well, let's find the period first, sorry. Period for sine and cosine is 2 pi divided by b. So in this case, b is this number right here. Since we don't see any number, 1 is implied. So period is just 2 pi over 1, which is 2 pi. So this function repeats every 2 pi. Let's find phase shift. For phase shift, I think convenient way to think about is what x value does make inside of this argument, inside of this cosine 0. So you can think it's just solving x plus pi over 3 equals 0 and solve for x. So in this case, x is negative pi over 3. Since we got negative pi over 3, phase shift is left to a pi over 3 amount, pi over 3 radian. Lastly, the midline is just this one, positive. So midline is y equals 1. Sketch 3 sine 2x plus 1. So of course, before sketch, we have to find all this information: amplitude, period, phase shift, midline, and always check for reflection. There's no negative multiply, it's just positive 3. So there's no reflection in this graph. So amplitude is absolute value of 3, which is just 3. And let's look at period. Period is 2 pi divided by b. In this case, 2 is b. So period is pi. And phase shift, there's none. Because, let me just write it just as a practice, although there's none, which means we can write 0. Phase shift means whatever makes inside of this 0, which is just 0. If I plug 0 for x, I get 0, right? So 0. That means it does not shift either left or right. And then midline, right here, midline is y equals 1. So now we have all the information. And how do we start graphing? We start by drawing primary points. So we want to always find primary points. And primary points is always the period divided by 4. So always divide by 4. So period in this case pi, so we have pi over 4. So what this allows us to do is we're dividing our one period to 4 different sections. And each increment is by pi over 4. So let me sketch that. We start from 0, and we increase each grid by pi over 4 and x-axis. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And you notice that 2 pi over 4 is same as pi over 2. 4 pi over 4 is just pi. Okay. So we divide into these 4 sections. And then let's mark our amplitude. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So amplitude is 3. So I'm going to sketch without midline for now. So we know that sine graph has this shape. Starts at 0 in one period. So we're going to start from here. And then it goes to 3 because amplitude is 3. And here is also 0. And negative 3 goes down here and go here. So if I connect this, right, these are not straight lines, these are curves. And of course, this is just one period. It repeats, right? It repeats forever like this because angle is coterminous, right? So the graph I just drew here, this is just 3 sine 2x. Now I'm going to apply the midline, which is essentially vertical shift, to draw the given function. So right now midline is y equals 0 here. So now midline should be y equals 1, so right here. It means the entire graph shifts by 1. So this 0 right here comes right here, go up 1. This point right here, go up 1. This one go up 1 right here. This one go up 1, go up 1. So it's convenient to move these 5 points. And these 5 points, again, obtained by the primary points. So then now we connect this like that. And again, make sure to draw an arrow to show that these graphs are repeating. And you can always just draw more, like I'm doing here. It's repeating. Right? But it's important to draw an arrow. So the final graph is, let me highlight it. Right here, this is the final answer. And usually you can draw 1 or 2 period. But we need to draw at least 1 period. So this right here is 3 sine 2x plus 1. Sketch negative 2 sine of pi x over 2. Now here we have negative. That means it reflects over x-axis. It's very important to notice that. Then let's find all the amplitude, which is absolute value of negative 2, which is 2. Let's find period. In this case, pi over 2. We can think as pi over 2 is multiplied to x. So period is 2 pi over b. In this case, b is pi over 2, which we can simplify to 2 pi times 2 over pi, which is 4. So period is 4. And phase shift, there's none because I can plug 0 here. So phase shift, remember right here, is 0, which is none. Midline is also none. There's no number added or subtracted here, right? So well, I should say none. Midline is just y equals 0. And we know the sine graph has shape of like this, right? So first, after you find all this information about the function, find the primary points always. Primary points. So primary points for sine and cosine is always the period divided by 4. So period for this function is 4. So we do 4 over 4, which is 1. So what does this 1 tell us? This is the increment we're going to make on the x-axis. And remember, for sine, cosine, tangent, when we're graphing this, the x represents angle in radian. So we're going to mark 0, 1, 2, 3, 4. So we draw one period, and each one period is divided by 4 sections. That's why it's called primary points. It actually gives us 5 points. Dividing by 4 sections gives us 5 points. So then amplitude for this graph goes up to 2, goes down to 2. So it starts at 0. Since sine started at 0, we 0 at 0. And we follow this shape. So this right here, again, important to draw an arrow because graph repeats. It's actually incorrect to not draw an arrow. Okay. So this right here is just 2 sine pi over 2x. We actually need to now reflect it. So let's see how we can reflect it. So for 0, it stays 0. Now this positive value becomes negative value. So right here, negative 2. 0 stays 0. Now this negative 2 becomes positive value. And 0 stays 0. So essentially the graph has this shape. Oops, let me draw it better there. Here. And here. Sorry, this is more like this shape. And again, it repeats. Right, so draw an arrow, draw an arrow. So this red graph right here is the final answer. Negative 2 sine pi over pi x over 2. Again, which is same as writing pi over 2 times x. So let me highlight the final answer. This is the final graph right here. Again, repeats, right? But we just draw one period. Sketch negative 2 cosine of pi over 2x plus pi plus 3. So first of all, the negative here means we reflect over x-axis. Then let's find all the information. So amplitude is absolute value of that value, negative 2, which is 2. Period is 2 pi divided by pi over 2, which is 2 pi over, 2 pi times multiply the reciprocal, which give us 4. So period is 4. Now phase shift, the way we find phase shift is whatever makes 0 inside here. So pi over 2 x plus pi equals 0. So for x, subtract pi both sides, negative pi. Multiply by 2 over pi both sides like this to solve for x. So this cancel out. So we have x equals negative 2. And you can always check. If you plug negative 2 here, this simplifies to 0. So negative 2 means that phase shift is left to 2. This is phase shift. And midline is y equals 3. So just like any other graph for sine and cosine, we first find the primary points. So primary points are a period divided by 4. In this case, the period is 4 right here. So 4 divided by 4 gives me 1. So what does that mean? This is the x-axis grid mark. Remember, x here is angle in radian. So we're going to start from 0, and we're going to mark 0, 1, 2, 3, 4. So we just marked one period. So let's graph this one step at a time. Let's graph with amplitude and period, and then we'll do phase shift, and then we'll do the midline. So let me start with black color. So here, let me actually make it better. So it's 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, negative 5. So now we have to remember cosine starts at here. Cosine 0 is 1. And cosine has shape of something like this in one period. So in this case, instead of starting at 1, it starts at 2 because amplitude is 2. So cosine goes through this point, this right here, like this. And we connect this dot with a cosine shape, which is something like this. Again, these are not straight lines. And it repeats. So draw an arrow. So this right here is 2 cosine pi over 2x. We have now reflected it, nor we haven't applied the phase shift, nor the midline. Okay. So first, let's apply the phase shift. Phase shift says go left to 2. Okay. So then what we think about it is, for phase shift, for each point we go moved left 2. So this right here is go to 2, left 2 units, 1, 2 radian. This one goes to 2, like here. This point moves to 2, which is at 0 now. 3, at the point at 3, it comes to 1, like here. So each of these 5 points move to left 2 units. Okay, so then we have this new 5 points, and it still has the same shape, so connect it like this. Okay, so then again, draw an arrow. So let me mark it. This purple graph is with the phase shift. 2 cosine pi over 2x plus pi. So now that we apply the phase shift, now we're going to apply the reflection. So let's try the reflection. Let me do with red. So for reflection, the positive value becomes negative. So this was positive 2, right? So positive 2 becomes now negative 2. So this kind of, you can think as reflect, so it goes here. 0 as 0 stays same. Now this negative value becomes positive, so come right here. And this 0 stays at 0, and this positive 2 becomes negative. So if I connect this like this red graph right now is after reflection. So let me write this. This here is negative 2 cosine pi over 2x plus pi. So now the last thing we have to do is apply this midline right here, right? We have to add 3. That means the entire graph just go up 3. So it is important to actually do the midline in the last step. We're doing this first and adding 3. Okay, so order is important. So we are saving the midline until the last step. So let me do the last one with the blue color. So that means each point, now midline has to be at 3. This is the midline instead of 0. This is at 0, right? So this is y equals 3. So you can think as entire point on the graph. Entire graph is going up 3, but just for purpose of graphing, we can say each point goes to up 3. So this one is at -2, so go up 3. So 1, 2, 3, so it's at 1 now, +1. This one is at 2. Oh, sorry, let's do this one. This is 0, so if I go up 3, this should be at 3, right here. This one is at 2, so if I go up 3, it should be at 5. This one is at 0, so if I go up 3, it should be at 3, right here, right on the midline. This one's at -2, so if I go up 3, it should be at 1. 1 as in, I'm talking about y values, right? So these blue are 5 blue points are the final one that will connect to finish the graph. So have this curve shape right here. It's kind of like a ghost, right? Ghost shape. And we can make sure to draw an arrow. So this one is the final answer. -2 cosine pi over 2x plus pi plus 3. So let me highlight the final answer. So we have a lot of graph here. This is the final graph. For the following function, find the stretching factor, period, phase shift, and asymptotes, then sketch the graph. So here we're sketching tangent graph. Oops, sorry. Which is a little different from graphing sine and cosine. So stretching factor is absolute value of this value. So let me write it. Stretching factor is absolute value of number multiplied to the entire function, 1 in front of the tangent function, which is 2. So that's the stretching factor. Now, period, unlike sine and cosine function, we have to divide by pi, not by 2 pi. Period for tangent is pi divided by absolute value of this function, this number right here. So in this case, pi divided by pi. So let me actually write b here, just like we're doing. So for tangent, we divide by pi, not 2 pi for period. Tangent, period, is pi divided by b. In this case, pi over pi, which is 1. So period for this function is 1. Phase shift, the wavefront shift is similar to sine and cosine, where we make whatever makes inside this 0. So solve for pi x plus pi equals 0. Pi x equals -pi divided by pi both sides, x equals -1. So phase shift is left to 1 radian. So now that we found stretch factor, period, phase shift, now we have to find the asymptote. And actually for sketching tangent function, having asymptotes will help us determine all this period and phase shift. Okay. So the asymptotes occur at x equals pi over 2b, or absolute value of b if b is negative. So let me just write that. Plus pi over b times k, where k is integer. Okay? So in this case, we know that pi, b is what? Negative. Also, b is pi. B is pi right here, right? This is capital B. So we have 2 pi over pi plus pi over pi k. We can do, or half, pi cancel out. plus 1k, which is just half plus k. So k is again an integer. So for example, when k equals, let's say, -1, we have 1/2 minus 1, which is -1/2. This is a asymptote, one of many. When k equals, for example, 0, we have half, which is also asymptote, one of many. We have infinite number of asymptote. When k equals 1, again, same thing. We have half plus 1, which is 3/2. And we can do also for 2, -2. We can find many, okay? And each asymptote, the distance between each asymptote is 1 period right here. Okay? So we want to sketch first asymptotes. So let me do that. -half, let's say, here's -1/2. Here is 1/2, and 3/2. Again, period is 1, so this distance is 1. And as you can see, there's also -3/2. So we have vertical asymptotes for tangent. That means if I plug these angles, these are radian, tangent is undefined. Okay. So before I actually sketch, there's another way, right? There's another way of finding asymptotes, or alternative way, is that just do the pi over 2b, which in this case is pi over 2 pi, and that is 1/2, right? And if you just find pi over 2b and multiples of odd integer, will also work. So if I do multiple odd integers, so I can only multiply, for example, 1, 3, 5, 7, or -1, -3, -7. So if I multiply 1 here, I get this. If I multiply -1, I get -half. If I multiply 3, I get 3/2. If I multiply -3, I get -3/2. So this is another just quick way of finding vertical asymptote for tangent graphs. And either this or this is fine. Both will give us the same result. Okay. And then why do we find the period? Period just affirms that each distance between asymptotes are 1. Okay. So then let's graph tangent graph. So for each period, there's this shape. Again, we're sketching it. We're not doing, doesn't have to be precise, as in, to plug some points. We can just, you definitely need to know the generic tangent graph shape, which is always this, right? And again, collection of all these. Here's the mid one. And we have infinite number of these, right? Repeating, same shape every period. This entire collection of this shape is one tangent graph. Okay. So this repeating, so repeating here, right? Repeating like this forever. So now, remember, we have to do reflection and midpoint. Here's the reflection negative. So that means it just has this shape right here. Reflect like this. So this is after reflection. Okay. And from this reflection, now we need to bring it down 1. So now midline is 1. So now midline is -1. So this midpoint, the starting point will come here. And from here, we draw the same, well, not same, we're shifting down. So think as shifting this entire red or the red graph to down 1. Okay. So let me highlight the final graph. This right here is the final graph. These, all these, right? Repeating. And make sure draw an arrow because it goes up. It approaches vertical. Well, it gets closer and closer to the vertical asymptotes, right? Infinity and negative infinity. So this is a tangent graph. And tangent graph, again, we're sketching it, is not as exactly precise compared to the if you were to graph in a graphing calculator or something like that. So just make sure you know the generic shape of tangent graph and know how to find the asymptotes.